The S1 was the steam locomotive that looked like it came from the future but couldn't escape the past. At 140 feet long with 6,000 horsepower under the boiler, it was supposed to make diesels look like a bad investment. It could hit 100 km/h hauling a full passenger consist, and when it moved, it looked like two locomotives having a conversation through a chassis. Most rail fans either worship this thing or think it was the exact moment PRR's engineering department lost the plot. I personally think it represents everything brilliant and tragic about late-era steam development. I wonder what would have happened if they'd built it 10 years earlier when the market still wanted to believe. So basically, back in 1937, the Pennsylvania Railroad was watching their flagship Broadway Limited get embarrassed by lighter, faster competition. The New York Central's 20th Century Limited was making headlines with Hudsons that could sustain 90 mph, and PRR's aging K4s Pacifics were struggling to keep schedules with increasingly heavy trains. The railroad needed something that could haul 1,000 tons at passenger speeds without helper engines on the grades west of Harrisburg. The problem was you couldn't just scale up a Pacific into that locomotive. Steam locomotive design by the late 1930s had hit some hard physics walls. Make the drivers bigger for speed and you lose starting tractive effort. Add more driving wheels for power and you kill the speed. Put the boiler pressure up and maintenance costs go vertical. PRR's mechanical department basically said, fine, we'll ignore convention entirely. In late 1937, they sketched everything. Articulateds, turbines, high-pressure compounds, triple expansion experimentals, the whole menu. Then they landed on something that looked insane on paper, a rigid-frame duplex drive locomotive. The duplex concept was simple in theory. Divide the cylinders and driving wheels into two independent engine sets under one boiler, like running two locomotives. On one frame. This meant each engine drove fewer wheels, so you could use smaller drivers without sacrificing total adhesion. Smaller drivers meant higher speed potential, and because the reciprocating masses were divided, you'd get less hammer blow on the track at speed. PRR assigned the project to the Baldwin Locomotive Works and tagged it Class S1 for super steam. The design brief was brutal: 100 mph capability, 1,000-ton train capacity, operation between Chicago and Crestline without helpers. And it had to look like the future because PRR was planning to debut it at the 1939 New York World's Fair. Power came from a 300 psi boiler feeding four 22-sex 28-inch cylinders arranged in two pairs. The front engine drove the second and third pairs of 84-inch drivers. The rear engine drove the fourth and fifth pairs. The wheelbase stretched 140 feet, making it the longest rigid-frame steam locomotive ever built. Baldwin and PRR basically had to invent new solutions for everything. The frame had to be rigid enough to handle 608,000 pounds of locomotive, but flexible enough to navigate curves. They built it with a hinged engine bed that allowed slight articulation without the complexity of a true articulated joint. Valve gear was a nightmare. Each engine needed independent poppet valve actuation, which meant rotary cam boxes driven off return cranks and enough linkage to make a watchmaker nervous. Track testing showed the system worked, but service access was basically high-friction city for the maintenance crews. Then there was the streamlining. PRR's stylist Raymond Loewy got involved and wrapped the whole thing in a shark-nosed shroud with a raked nose, skirted running boards, and a completely enclosed cab. The result looked like a Buck Rogers fantasy. Somebody said it was like putting a tuxedo on a cathedral, which is excessive but captures the vibe. The S1 rolled out in January 1939 and immediately went to the World's Fair. It sat on display for 18 months, polished to a mirror finish, and became one of the most photographed locomotives in history. The public loved it. The press called it the big engine and speculated PRR had just saved steam from the diesel threat. But here's the thing. While it was sitting at the fair looking pretty, the actual performance testing barely happened. PRR ran limited trials in late 1939 and early 1940, and the early results were complicated. Top speed test runs suggested it could hit the century mark, maybe even exceed it, though PRR never officially confirmed anything over 100 mph. Acceleration was impressive, coal consumption at speed was manageable, but the wheel slip problem showed up immediately. And the biggest practical complaint wasn't even about performance. It was about one simple question: Nobody at Baldwin or PRR properly answered during design. Where exactly do you turn this thing around? So this is where PRR basically admitted they'd built a locomotive that worked brilliantly in theory but couldn't survive. Contact with the real railroad. They honestly thought the engineering genius would overcome the practical limitations, that the speed and power would justify the compromises. But the operating department bluntly seemed to care about two words: availability and flexibility. The S1 entered actual revenue service in early 1940, assigned to the Crestline Chicago run on the Broadway Limited. And immediately, the problems started stacking. First, the duplex drive arrangement that looked so clever on the drafting board had a fatal flaw. The front and rear engines weren't mechanically linked. On a conventional reciprocating locomotive, all drivers are connected by side rods, so if one pair slips, the others keep driving and help it recover. On the S1, each engine was independent. That meant if the engineer opened the throttle too aggressively, especially on damp rail or starting a heavy train, one engine would slip while the other grabbed. The result was this lurching, violent motion that could throw passengers around the cars and damage track. Engineers had to feather the throttle like they were landing an airplane, which killed the acceleration advantage. PRR tried to fix this with sanding improvements, different valve timing between the engines, and crew training that emphasized smooth throttle application. The handbook basically told engineers to treat it like a 600-ton piece of glass. But the physics didn't care about training. The front engine always wanted to slip first because weight transfer during acceleration lightened the front drivers. The slip problem got so bad that crews started calling it the Big Slippery. Maintenance crews complained that the violent slipping was cracking the frame castings and loosening every fastener on the running gear. And here's the worst part. Because the engines were independent, when one slipped at speed, the uneven power delivery would cause lateral oscillation that felt like the whole locomotive was trying to shake itself apart. Then came the infrastructure reality that should have killed the project before it started. The S1 needed a turntable at least 140 feet long. PRR had exactly two. One at Crestline, one at Chicago. That meant the S1 could only run on one specific route, and if anything went wrong at either terminal, the locomotive was basically trapped. Conventional practice was to turn locomotives at every terminal to balance wear and ensure proper forward visibility. The S1 couldn't do that on most of PRR's system. They tried running it backward on some trips, but the streamlined shroud made rear-facing operation dangerous because the engineer's visibility was basically non-existent. PRR looked at installing larger turntables at other terminals. The cost estimates came back and basically said you could buy 3 or 4 modern Pacifics for what it would take to modify one terminal for S1 operation. The railroad quietly shelved those plans. Remember that beautiful Raymond Loewy streamlining? It became a maintenance crew's nightmare. Every time something needed service, which was often because this was an experimental locomotive with complex valve gear, the shrouding had to come off in panels. What took 2 hours on a conventional locomotive took 8 on the S1. The poppet valve gear, which promised superior performance, delivered on that promise, but at brutal maintenance cost. The rotary cam boxes required precise timing adjustments every few hundred miles. The return cranks and eccentric straps wore rapidly under the heavy reciprocating loads, and because everything was tucked under the streamlined casing, simple inspections required major disassembly. The S1's tender carried 19 tons of coal and 2,500 gallons of water, which sounds massive until you run the actual consumption numbers. At sustained high speed with a heavy train, the locomotive could burn through the entire coal capacity in under 300 miles. Water consumption was even worse because the high boiler pressure and large cylinder volume meant constant evaporation. PRR's Crestline Chicago run was 282 miles. On paper, the S1 could make it. In practice, conservative engineers would often call for coal and water stops to avoid running short. That killed the schedule advantage and made the whole speed capability pointless. Put all that together, and what looked like engineering brilliance turned into operational liability. The S1 could do things no other steam locomotive could do, but only under perfect conditions with unlimited maintenance support and infrastructure that didn't exist. And then the war changed everything. When Pearl Harbor hit in December 1941, the conversation around PRR's experimental locomotives basically evaporated overnight. The Office of Defense Transportation issued orders prioritizing troop movements and war material. Passenger schedules got looser, freight tonnage requirements went vertical, and every serviceable locomotive got pressed into maximum utilization. For the S1, the war years became this weird validation period. Suddenly, the limitations didn't matter as much because PRR needed every available high-horsepower unit, and the S1, despite its quirks, could move heavy trains fast. The railroad pulled it off the Broadway Limited and started using it where its strengths actually matched the mission: long-distance, high-speed troop trains that didn't need frequent terminal turns. This is where the S1 briefly became what it was supposed to be. With wartime loads often exceeding 1,000 tons and priority schedules demanding sustained speeds above 70 Mbps, the duplex drive arrangement finally made sense. The front and rear engines working together could maintain boiler pressure at speeds that would have conventional locomotives gasping for steam. Crews reported, when conditions were right, that the S1 was the smoothest riding steam locomotive they'd ever operated at speed. The divided reciprocating masses really did reduce hammer blow, and on well-maintained track, it could hold 90-plus mph with a stability that impressed even skeptical engineers. There are persistent stories, never officially confirmed, that the S1 hit 120-plus mph on the Fort Wayne-Chicago stretch during a wartime troop movement in 1942. PRR never verified this. Baldwin never commented, but multiple crew members over the years claimed they saw the speedometer pegged and kept climbing. Whether it actually happened or became railroad folklore doesn't really matter. The fact that people believed it could do it says something. The acceleration capability proved valuable too. Wartime operations meant irregular schedules with frequent stops for priority military traffic. The S1 could get a heavy train back up to speed faster than almost any contemporary locomotive, which helped keep the system fluid when every minute mattered. But the wheel slip issue didn't care about the war effort. It actually got worse because wartime maintenance standards were lower and track conditions deteriorated under heavy use. Engineers learned to work around it, but that meant the S1 required more skill to operate than standardized locomotives. In a wartime environment where railroads were hiring less experienced crews, that was a liability. The maintenance burden became crushing. PRR's back shops were overwhelmed with war traffic, and the S1's complexity meant it spent more time out of service than comparable power. A standard K4's Pacific might need a classified repair every 90 days under wartime loads. The S1 needed heavy attention every 45 days, and the work took twice as long. The streamlined shrouding started coming off in sections and just stayed off. By 1943, the S1 looked less like Raymond Loewy's masterpiece and more like a skeleton wearing parts of a tuxedo. The cab shroud remained, the nose shroud survived, but most of the side skirting disappeared into scrap drives or maintenance neglect. Parts availability became a crisis the S1 shared almost nothing with PRR's standard locomotive fleet. Every specialty casting, every custom valve component, every unique bearing assembly had to be fabricated individually. With Baldwin's Works running at maximum capacity building standard locomotives for the war effort, S1 parts requests went to the bottom of the queue. Here's the thing that really reveals how PRR felt about the S1 by mid-war. They didn't build more. In 1942, PRR ordered a fleet of production duplex locomotives from Baldwin, the T1 class. These were smaller, lighter, and designed from the start to avoid the S1's operational problems. They had 80-inch drivers instead of 84, better weight distribution to reduce slipping, and a frame short enough to fit standard turntables. The fact that PRR took the duplex concept and redesigned it from scratch, rather than ordering more S1s, basically told the industry everything. The S1 was a proof of concept, not a production design. It showed what was possible, but also showed exactly how not to do it if you wanted a locomotive you could actually deploy across a railroad system. Baldwin built 52 T1s between 1942 and 1946. They had their own problems, slipping, complexity, maintenance, but at least they could operate system-wide. The S1 remained unique, which in railroad engineering means mistake we didn't repeat. By the time the war ended in 1945, the S1 had logged more miles and moved more tonnage than anyone expected when it sat gleaming at the World's Fair. It proved steam could still compete on raw performance. It showed that duplex drive could work under the right conditions. But it also proved that brilliant engineering without operational pragmatism was just expensive sculpture. And the thing nobody wanted to say out loud yet, diesel-electric locomotives were logging even more miles with a fraction of the maintenance headaches. The future the S1 was supposed to prevent was already arriving at the terminal, so not long after VJ Day, PRR's management started asking questions that made the mechanical department uncomfortable. The war had proven that diesel-electric locomotives could run 10,000-plus miles between shopping, needed smaller crews, didn't require turntables or water stops, and could be operated by less skilled engineers. The EMD-FT demonstrator had logged 83,764 miles in 11 months across 20 different railroads. The S1 was lucky to hit 40,000 miles a year and spent a quarter of its time in the shop. The S1 went back into passenger service on the Broadway Limited, but now it was competing against EMD's new E7 passenger diesels that PRR was testing on the same routes. The comparison was brutal. An E7AB set cost about $400, roughly what PRR had invested in the S1 when you counted development and special infrastructure, but the E7s could run Chicago, New York without turning, carried enough fuel for multiple round trips, and required maintenance measured in weeks instead of days. When you line up the S1 against what the market actually wanted in 1946, the positioning problem becomes obvious. Take the EMD E7 passenger diesel. 2 units in AB configuration produced 4,000 horsepower continuous, could sustain 90-plus mph indefinitely, and carried enough fuel for 800-plus miles of operation. Crew size was 3 men. Maintenance intervals were monthly. Terminal turnaround time was however long it took to check fluid levels and couple to the train. So you're getting comparable speed and power with dramatically lower operational overhead. The turntable problem never got solved. By 1946, PRR had looked at the cost of upgrading terminals for S1 operation and basically laughed. The railroad was spending capital on electrification extensions and diesel facilities. Nobody was approving million-dollar turntable installations for one experimental locomotive. This meant the S1 was permanently locked into the Crestline Chicago corridor. Any road expansion required either building new infrastructure or running the locomotive backwards, which was dangerous and unpopular with crews. Here's where the economics turned completely against the S1. Baldwin Locomotive Works was retooling for diesel production. PRR's Altoona shops were shifting focus to diesel maintenance. The specialized craftsmen who understood the S1's poppet valve gear and complex running gear were either retiring or being reassigned to diesel training programs. Parts that had been difficult to source during the war became nearly impossible post-war. Custom castings required pattern making and foundry time that Baldwin wasn't allocating to one-off steam components. Lead times stretched from weeks to months. The S1 made its last revenue run in late 1946. PRR didn't announce it, didn't ceremonialize it, just quietly pulled the locomotive from the Broadway Limited roster and sent it to storage at the Altoona facility. The decline was shockingly fast for a locomotive that was barely 7 years old. For about 18 months, the S1 sat in Altoona, officially stored serviceable. That's railroad speak for we don't know what to do with this yet. PRR occasionally floated ideas, maybe donate it to a museum, maybe rebuild it with modern roller bearings and improved valve gear, maybe convert it to a stationary boiler. None of it happened. Museums didn't want it because moving and displaying something 140 feet long and 600,000 pounds was logistically impossible for the small railroad museums that existed in the late 1940s. Rebuilding it made no economic sense when the entire steam program was being phased out, and converting it to stationary use was actually more expensive than just buying a new industrial boiler. In May 1949, PRR management made the call. The S1 would be scrapped. The official reason was obsolescence and non-standard design making maintenance economically infeasible. The real reason was simpler. It was worth more as scrap metal than as a locomotive, and keeping it cost money they weren't willing to spend. The scrapping happened at Altoona in summer 1949. Workers cut the streamline shrouding off first. The aluminum and stainless steel had decent scrap value. Then they sectioned the boiler, cut the frame into transportable pieces, and separated the running gear. The whole process took about 6 weeks. Nothing survived. No builder's plates, no components saved for museums, no last-minute intervention by preservation groups. PRR scrapped it as thoroughly as if they were trying to erase the mistake from the record. When you look at why the S1 failed while its competitors thrived, the story is really about mission mismatch and timing. PRR positioned the S1 as proof that steam could match diesel performance. But that was never the real competition. Diesels didn't win on horsepower or speed. They won on availability, flexibility, and operational cost. An E7 diesel might have been slower than an S1 at 100 mil /h, but it could run 20 hours a day for weeks between service stops. The S1 needed daily maintenance and weekly heavy inspections. By fighting on performance instead of economics, PRR was answering a question the market wasn't asking. One decision could have changed everything. Build it smaller or don't build it at all. So nothing physical survived the S1's scrapping, but the influence lived on in weird ways. The duplex drive concept, dividing cylinders and drivers into independent engines, showed up in PRR's later steam designs and influenced thinking at other railroads. Norfolk and Western looked at duplex arrangements for their passenger power. The Chesapeake and Ohio experimented with similar concepts. Even Baldwin used lessons from the S1 when designing steam turbine electric locomotives in the late 1940s. The streamlined aesthetic influenced industrial design beyond railroads. Raymond Loewy used elements of the S1's shark nose and flowing lines in other projects. You can see echoes of it in the later Pennsylvania Railroad GG1 electric locomotive, styling and in Loewy's work for Studebaker automobiles, but the most important legacy was what it taught about engineering hubris. The S1 became the case study used in engineering schools and railroad management programs for decades. Brilliant solution to the wrong problem lectures inevitably featured a photo of that gleaming 140-foot locomotive that couldn't find a turntable. In enthusiast circles, the S1 achieved legendary status precisely because it was scrapped. The lack of a preserved example made it mythical. Those disputed top speed claims, did it hit 120, 130, did it really happen, became railroad folklore because nobody could prove or disprove them. The speed stories got more elaborate with each retelling. Some claimed it hit 140 miles at its Pike-8 on the Fort Wayne division. Others said PRR deliberately destroyed speed records to avoid encouraging unsafe operation. The truth probably lives somewhere boring. It likely hit 110 to 115 mph under ideal conditions, which was impressive, but not physics-defying. Here's the tragedy from a historical perspective. If PRR had donated the S1 to a museum in 1947 instead of scrapping it in 1949, we'd have the most spectacular preserved steam locomotive in America. That streamlined bulk, those massive drivers, the sheer presence, it would be the centerpiece of any railroad museum. But 1940s museum infrastructure couldn't handle it. The buildings didn't exist. The transportation methods to move it safely didn't exist. The money to maintain it didn't exist. Looking back from 75-plus years later, the S1 represents a specific moment in technological transition when one paradigm was dying and engineers tried to save it through brilliance instead of accepting economic reality. It's the steam locomotive equivalent of building a better horse-drawn carriage in 1920. Impressive craftsmanship applied to a dead-end technology. But here's the thing. It wasn't stupid to try. In 1937, nobody knew diesel-electric would dominate. Within 20 years. Truth is, one lever could have changed a lot. Build it as a pure research platform, acknowledge the limitations up front, and use the learnings to inform the diesel transition instead of fighting it. Instead, PRR tried to make it a practical locomotive, failed, and erased it from existence. Now all we have are photographs of something that looked like the future but couldn't escape the past.